Hello, everybody, and a very warm welcome to you on this wonderful Wednesday afternoon. My name's Ciaran. I work in our technical sales department here in Renningen in our headquarters. And today we are going to be presenting a new product and a bit of a new topic, which is our LoadSolver, which is a little product that we have here. Joined with me, I have Juliana from our product management team. Maybe you could give a little presentation
Yes,
of
sure.
yourself.
Hi, my name is Juliane. I'm from product management for K2, working for a year now. And you don't hear it in my English accent, but in German, I'm living in Berlin, so you would recognize then.
Yeah, so if you're ever in the Berlin office, you can go say hi
Yeah.
to Juliana. So for those of you who have not joined us before, our webinars will run very similar to those in the past, where we will be bouncing back and forth a little bit. We'll be presenting some of the products that we have here. We'll also be going through a little presentation online, and we'll be going through our base software. If you have any questions throughout today, we would really like to hear them. It helps us interact a little bit with our audience and can provide you a little bit more and more precise details. So if you do have any questions, please put them in the Q&A section of your Zoom. So depending on your language, it might be a little different, but down the front here somewhere of your Zoom, you should see a Q&A or something along these lines button. It just helps us track the questions a little bit better, and so we're not just sifting in and out of the chat. The webinar today will be recorded, and I think we're also on YouTube as well, so you will be able to access it later if you would like to, and the presentation will be sent out as well. So that usually covers most things. I think we will. We also have Vlado in the background, so if you do have any questions, you might get some typed answers from him. But if there's something that pops up that is really relevant to everyone, we might change the course of the webinar a little bit to answer those specific questions. So I think that about covers all of it, would you say?
I think so.
All right, then we will jump into a bit of a presentation first to describe why we have the LoadSolver.
And what he's going to solve.
And what it's going to solve, exactly. So I think you should be able to see me now. So in general, the LoadSolver is a product that we have to look at the issue of insulation on insulated roofs, sorry, the thickness and the strength of insulation on different roofs. Because when you're going to add something to an insulated roof, you are putting a weight on it that might not be expected to be there as per the insulation manufacturer. And how is that going to interact with the roof? Maybe it's unknown, maybe it is known, maybe it can be predicted. And the shape and size of this extra weight on the roof plays a role. So the topics of today will be a little bit about some of the regulations which are defining that size and weight and force that you can put on the roof. We'll also go through a little example that we have or taken from some roofing manufacturers that we've been in discussions with. We'll also go through a little base project and talk about the product in a little bit more details. So we gave a presentation in German earlier this morning, which was very focused to the German market. But while researching for this webinar, we've found that really the regulations are quite different in every country. And so it's a little bit difficult for us to give a very precise region-specific information. So our first kind of over point, and this is a very important one for today, is that each different country has slightly different regulations and topics that relate to this specific problem or topic. And so in the different countries, you can see them here. These are usually to do term with building codes, and specifically for some of them insulated products, whether it be walls or roofs. And there's a few examples that we have here in the UK and some of the Nordic countries, and a bit around Europe as well. So we're going to present a specific calculation that's relevant to the German regulations today. It may be relevant to some of the presentation or some of the regulations you have in the country that you're from, but please be aware, revert to these standards when you're looking into this topic for yourself. So one thing we can say, though, as a bit of a general overview, is that almost all roofing insulation companies have a factor that the roofing material has to be tested to and has to meet, generally speaking, to be placed on roof. And this is the CS10, the compression of 10% with 70 kilopascals. So this is something that's more so designed for like a standard minimum requirement for a roofing building, rather than saying if you put on a very concentrated load of 70 kilopascals, it will only compress 10%. That's not what it's doing. It's more of a general overview of saying it's met this requirement, tick, it's then suitable for the roof. Doesn't necessarily mean it's going to be suitable to put PV on that roof as well. Another one that is often used, and we'll go in a little bit later with one of the manufacturing we've spoken about, is the 2% compression. And so this is for permanent or semi-permanent loads that are applied to the roof. And this is something that's more suitable for PV, but again, it is dependent a little bit different on with different roofing manufacturers and also in different regions as well. So we'll be focusing a little bit more on this 2% value, but as I said, please refer to the local standards and the roofing manufacturer. So that's kind of the next point. So we did the presentation earlier this morning in German with Knauf, which is a German manufacturer. Well, I believe they're German based, but they do have branches all over the place. For example, they do have one in the UK and Ireland. And this is the information that they have on their website that we presented, or we didn't present this morning, but you'll see on the next slide we did for the German one. This is what they're specifying in Europe. So for the different sized feet that you might have on a roof, or a pressure point that you might have on the roof, they have different allowable stresses or pressures. And so for a 200 by 200 millimeter square foot, you can have up to 12 kPa, right? But it does also say halfway through this paragraph here that these are references only, right? And to be in contact with their technical service team. So they are the ones, Knauf in this specific case, who can give you an exact value when you say, I would like to place this on the roof, it has a size of this, and then they can provide you with this maximum kilopascal force. Knauf in different countries, and this is what you also might see as well, in Germany, for example, have a bit of a different system, and it's a little bit more in depth, I would say, where they've actually gone through already and calculated for a number of different sizes. And you see here the meter by meter, half a meter by half a meter, all the way down, that for all of their different products, they have different pressure values. So these values here, I'm just highlighting these ones because we'll talk about it in a moment, kilopascals. And so for what we're talking today, our products have roughly a surface area of 0.03 meters, which is roughly this size. And so we can use a maximum kilopascals of 35. Right? We've already been in conversation with Knauf about this. And so the different manufacturers you see here have different regulations for not only their roofing types, also the surface area of the pressure point, but they also have the different calculation or different references in the different countries as well. So the roofing manufacturers are also aware of this, that the different regulations are there, and so they handle it a little bit different as well. And so any future projects that you might have will probably be a three-way conversation between the roofing manufacturer, yourselves, and us, hopefully to find the best solution that we can. Another example is another company, and this is also again in German because this is the regulation or the reference from the German side, where they are aware that people are putting PV on their roof, and they have now provided a very good overview of under what roofing types that they have here, with the rough idea of how it'll be supported. So whether it be a big flat plate or a sort of a longer concrete block or smaller pads that you see here. under each different condition, you have a different load that is suitable for this situation. And so for something like this makes it quite easy, I think, because you have these values right there and then. But again, in the different regions and the different areas, you might have different requirements and different points of reference to the maximum pressure that you are allowed to have on the roof. And this is effectively what the load solver is here to work with, which is how do we achieve these values here with the products that we have in our system. And to go through how we're dealing with that, I'm going to pass over now to Juliana to show some of the product
Yes.
in a bit more detail and continue with the presentation. So Klaus, could you just swap over maybe?
Hello again. Well, maybe we start just to show you what we currently have in our portfolio. So most of you guys probably know our Mat S. You can see it here installed below our rail. Mat S itself has a certain size of 380 versus 75 millimeters. So if we multiply this, it's around about 0.03 square meters. Not exactly, but quite off. And here again, we have our load solver. This is basically also our Mat S, as you know from the profile here, but it's smaller, so we only have a length of 200 millimeters. The width stays the same. And what's the difference? If you take our Mat S and put it below our rail, it will be like this. So the Mat S will lay under under our basic rail, where instead, if we go with our load solver, the installation will be done like this. So we go with our load solver and just put it in here, and you have that sound, and then it's installed. So these are the two products we are going more into detail now. And it's important for you to know the sizes of those two components, to know, if you go back into the overview Ciaran just shared with us, to know what exact number you have to choose. The second information you need if you want to have the right value is you need to know what is actually the insulation that has been installed. So where is your roof and what is the insulation? This is there's a certain value, and this one you have to compare with the roof surface of the Mat S and of the load solver, or a combination of both of us. So I go over there. I have a slide there I want to share with you. So you can see me now again. So what you can see here is there are different options how you can spread loads above the surface. If you have a full surface ballast, which we don't have in our case, it's pretty easy to see how the load will be spreaded. But if you have a smaller area, such as our Mat S, you will see that the pressure is working kind of different onto the surface. Also important to know is that snow load is a main contributing factor for this calculation. And for those who are more deeper into this topic, the safety factors always stay 1.0. If you then take a look into our K2 base and you want to know what is the value that you need to consider, it's LCC1. This is the one that has to be applied if you want to compare these values. So, anything okay from your side? Yes, perfect. And we go to the next slide. I think here it's a little bit more easy to understand what I'm talking about. So we have now the overview of the table from Knauf. And let's just assume that the customer or you are using DDP2U space 70. This is the one here in the first line. And as I told you before, our Mat S has a value of round about 0.03 square meters. So these 35 kilopascal are this is the value that we need to take into account if we then jump into our base and want to check if these two values are a good combination or not, or if there is maybe an overload, as you can see over here in this example that we have prepared. Okay. Assuming there is an overload, First of all, there are some pretty easy possible solutions you need to consider. The first one is double check the layout. Do you have certain panels that are standing alone or that are very close to the roof edge, or maybe the gaps you can adjust them, or stuff like this? Just check this before. Also, maybe first option, 25 years of wind, is that maybe enough for the calculation? Have you checked the friction coefficient? Have you measured this onto the roof? And the first option that we want to show you now in our base is use the additional Mat S. So the first thing is to increase the numbers of Mat S that are below the basic way and that are distributing the load onto the roof. Second option, use our LoadSolver. I just presented that to you. You can double check if it's a possible solution. And other option, maybe switch to our classic LS system, because you have simply more rails below the panel, so the load distribution will be bigger anyways. But let's just start with the additional Mat S. You can see it here. In general, when we start with the installation, you only have one Mat S laying below two SDs, for example. You can see if you click on additional Mat S, we will increase the number of Mat S below the system. Depending if you go with a classic system or express system, this varies a little bit, as you might know. For the Dome 6 Classic, it's nearly twice as many Mat S as you have had before, which means a reduction of the weight per load point. This is how it works. You need to evaluate you need to find out what is a certain value you need to see. It's 35 kilopascal, as I've mentioned before. Then you put this value into the base, and you click on additional Mat S. And as you can see here, we are now with 118% of pressure on the installation. It's still too much. That's why we are going to show you other options afterwards, but it is also already much better than the value we had before. Okay. Just for you to know what values you have to check. If you take a look into the base project report, you can see the value for the peaks and for the SDs, and then you just compare it with the values from Knauf in our example, and see if it's already sufficient, and if not, you need to go ahead with further options how to reduce these loads. So we have just seen it's not enough yet. Yeah, do you dump into this?
No, I'll do it over this one.
Okay.
Yeah. So just maybe to go through that, if you just jump out.
Yeah.
And then we can jump.
You go do it in base.
Into base.
Okay,
then,
let's go for it.
Just to kind of show you where this process is. If you haven't used base before, if you have used base before, you probably are already aware from the little snippets that we just had. But if you have not, we'll just go through this very quickly as well. So this is a project that we've prepared earlier, just next to our old office, actually, in Germany. And we've done a fairly standard flat roof system. We have a D-dome. We can put our through, so we've got the D-dome Classic. And on the results page, so right at the end, you see this green tick of everything in an order. And this means that all of our products meet the wind and snow expected loads in this location as per the tests that we've done with our products. You can click on here and you see that these are met by the certain percentage factors here. So in the terms of the uplift and the snow, we have 43% and a 29%, and we need so much ballast. We can also now add into this calculation a next factor, and this is relatively new in base as well, where we can say, don't just test our products, but also test the maximum factor of the insulation. And so in this case, we had put in 35,000 pascals. And you see now it comes up with something is overloaded. So the calculation or the input values that we've all had done here have not changed at all. The situation remains exactly the same. We're now just calculating with one more criteria that we'd like to meet. And if you click on the end, you now see that there's this extra factor here as well, the pressure on insulation. And this is now 221% of the 35,000 pascals that we have in here, right? And so this is the too much. This is the 221% that we had before. And then Juliana said we could add extra Mat S. This was shown in the PowerPoint as well, where we're going to put now 2 Mat S under each peak and under each SD. And by increasing the surface area by effectively double, we should see it's not quite halved usually because just the way the ballast is placed, and also it's not a linear translation. So sometimes when the ballast is in different places, we're not going to go exactly 1/2 of what it was before. But as ballpark, you can say it's going to be maybe about 60% of it. But you'll see it here straight away. But again, you see now our material hasn't changed, right? This is still acting at exactly the same point, but the pressure which is occurring on the roof, so the force is still there, but the pressure is now being distributed over a larger point, and so you can we achieve a much lower pressure. In this case, however, we are still over that 35,000 pascals, which we are trying to achieve. So what you will sometimes see here, it just takes a little while to pop up, is there sometimes there's a little question mark that you can click on, give you a little bit more information. And in this case, we cannot achieve this 35,000 pascals. It's a good idea to click on this little button now, and you get the option of taking it a little bit further. And so this is where the LoadSolver comes into it. And this is a calculation that we will be doing internally for the time being. It may be integrated and based in the future, but right now we're going to look to do it as sort of a case-by-case process. You can request a bit more details by clicking on this button here, and it will take you to the bit of a checklist or a request form where you can fill out all of the information that you have. Effectively, we just need your K2O file, and from there we can take the project and calculate in a little bit more detail. Obviously, the more information you give us, the better, because otherwise we're going to have to go back and forth a little bit. But the most important one being this K2O file. So to get to this slide or page, you can go through base. You can copy this part here, but you can also quickly scan this QR code if you're up for it. And it will go into a process that our internal sales team, so the team sort of I'm part of, and we've got a team across all different areas of Europe who can calculate this for you, will go into it and calculate a little bit more detail. So this is the page that we have here. And the LoadSolver is, I don't know, Juliana, did you go so much into the LoadSolver? Would you like to go into a little bit more with the physical
I think I've explained that before, but if you want, we can just jump back.
I think we can continue with the presentation then.
Okay, let's go.
So one idea that we discussed before was adding an extra Mat S. So this will sometimes be suitable, however, sometimes it may not be suitable. It may also be a more cost-effective solution, not to add a full Mat S, but just to add a shorter one, right? Or maybe you don't need so much space, right? So instead of having 2 lots of the 0.3 square meter Mat S, you could have maybe only 1 lot of the 0.3 meter Mat S and 1 lot of the LoadSolver, and achieve a surface area that is a little bit larger, but not so large that it's unnecessary. You might also find in some cases, if you have quite narrow modules, you actually can't get all of the Mat S in as well. This is a bit of a rare occurrence that would happen, but because the Mat S always just line up, you run out of space effectively. So instead of laying the Mat S in the direction of the rail, you can actually now put this load solver perpendicular to the rail and utilize the space a little bit more detail. What is also sometimes the advantage of this is that in a base project, you will have different ballast values in different regions. And so when you click the Mat S button, it's just going to put Mat S everywhere. You might not need them everywhere. You might only need them in certain locations. And as part of the load solver calculation that we're doing, we will sort of try and optimize, or we will optimize, the location of these load solver products to meet the requirements of the roof as per the ballast plan. Right? So it is a bit more of a specialized or precise calculation that we will do with a product such as this. The other point that we have as well, it actually can be calculated a little bit differently as well, where when we are adding a Mat S as well, we're actually going to be increasing the area of the area that the force is being applied to a little bit. So we're going to jump from the 0.3 square meter foot to now a 0.4 square meter foot, roughly. And this now actually changes the pressure on the roof that needs to be calculated as well. But this is something that we'll be looking at internally as well. So it's just something for you kind of to be aware of, something just to keep in the back of your mind, that as you do increase the area, the maximum pressure will reduce, because if it was to stay the same, you're just going to end up with a huge kilogram load on that roof, because force is inversely proportional to the area, and so the pressure must be reduced in this case to ensure that just the dead weight or the kilogram load, whether it be due to snow or ballast or panels, doesn't exceed and get too high. This kind of gets into a bit more technical part, because we are then effectively having a bit of a ordinary differential equation effectively, where we're jumping back and forth. So I don't want to get into this in actually too much detail. So I think we might just now end our presentation, because I think this is our last slide, which is good. And we will, I don't know if we can jump over, or maybe you can stand there, Juliane. I'll look to see if we have any questions that have been. I think Vlad
I think there's no question yet.
Already added
maybe just an additional information. If you pass over that project to us, we will do the calculation internally. And I think what's important to you is that at the end, you will receive like a document saying, okay, it's all fine. So at the end, we will give you the best type of combination, maybe in different areas, different combinations, but you will receive a document saying, okay, under this SD, one Mat S and one load solver will be sufficient, whereas maybe under the peak in the edge area, you will need to put 2 load solver and 1 Mat S. That's all possible. But you will receive an overview from us with the bill of material and the document saying, okay, it's all fine. I think that's important for you to know.
Yeah, and we actually just have a little sample of that here, which maybe we could present.
Perfect.
So this is effectively an appendix that we would attach on to the base report, or send it as well as the base report, which highlights the requirements that your project has and the requirements that the roof manufacturer is specifying for that specific roof. So in this case, maybe we have the permissible surface pressure of 50 kPa. And each project, if you're used to base, you'll know it, and you'll see it before, where you have different ballast values all over the place. If you're not so used to base, maybe I can quickly just show you a little bit what I mean. So here we have on the corner, we have 22 kilograms, but in the middle we have 3 kilograms. Here we have 2.5 kilograms. And you can imagine over a large roof, there's going to be lots of different values that need to be placed at these different locations. So the pressure under this section is going to be a little bit different to the pressure under this section. And we're going to need to increase the surface area here more than we will here. And what we're trying to specify, or what we are specifying in this section of this document, is that between a ballast value of 0 and 20, and it's placed in a certain location, then we can either add something or specify the minimum requirement in terms of surface area. Maybe it's a Mat S, maybe it's 2 load solvers, maybe it's a Mat S and a load solver. All of that is specified here, and we'll try and, or we will, as I said, optimize it to a point where you have, I think we could actually even optimize a number of criteria. So if you were looking for just the most general, easiest installation, we could optimize it in terms of that. If you're looking for a cost-effective one, we could also optimize it in terms of that. Or if you're looking for one that is just reducing the pressure as much as possible, that would also be suitable as well. So this is, again, a bit of discussion that needs to be had between yourselves and us, because we can provide solutions to fit different needs as long as we know what those needs are. So it's always good to have a bit of a conversation about that. We did have a question that just popped up, which Juliana, maybe you can answer this one, about the fire rating for the Mat S product and the PV products from Mike, maybe? So
is that in terms of the fire rating of the insulation, or is it more of the mounting structure? I'm not sure
it'd be
about
the mounting structure.
So
so the aluminium components, and please now correct me if
there is no issue.
If I'm wrong, there's no products there, and I know we have done recent tests on the Mat S.
Well, we have done a lot of tests on the Mat S. Yeah, sure. I think there is no issue with that.
Okay, so you heard it.
I mean, it depends on where you are. That's what we need to see. There are certain requirements we know, like BWOOF 3, 2, 1, whatever. That depends a lot, and this is what we need to check. For example, we have solutions if it comes to the French market, where we have passed the BWOOF 3T tests, and so you can be sure that this is suitable.
Yeah, and so for the team in the UK, or I should say, for the customers in the UK, we have a team in based just outside Reading, and they will be able to answer actually any questions you have on the local requirements in terms of the fire safety. So, I mean, the Mat S is a product that we've been using on the roofs in the UK for 3 to 4 years now. I would be highly surprised if it had not met any of the fire requirements. And the material that is new, effectively, is just a piece of
sheet
metal on top. So this is also part of, or comes into a very high fire rating class, because it's not a product that's really combustible. The
there's an answer.
Roof T4, is that a
Roof T4? I think we should. Maybe we can talk about this later. I'm not really sure. About this.
So Mike, thanks for that question. It's quite detailed. If you could maybe send us an email, we can get back to you on that and just follow up on this point. I think, Klaus, maybe you can put the email into the chat. Yeah, into the on the screen. It might have just popped up, but we can also put it in the chat as well. I'm just looking at the other questions that has come up here as well. I think, Stefan, we might have to get back to you on this one as well in a bit more detail. The values that we are given from, or the values that are from the roofing manufacturers, are ones that they should be able to answer this question. So we can obviously help you get in touch with them and follow up on this, because it's useful information for us as well. However, we can't comment on the tests and the safety factors that they've put into their calculations and their specifications. So if you also to send us a question, an email with the question as well, we can follow that up with, whether it be Gnalf, or if you have an insulation company that you're using, maybe we can always have a bit of a, as I said before, a three-way conversation where we're figuring out what the best solution forward is for that.
Okay. Anything else?
I think that's most of them that have popped
Okay.
up for the moment. So we'll begin to then wrap up. Thank you everyone for joining today. We have tried to provide a bit of an overview of a topic that's not specifically ours, but we are the interface between the roofing manufacturer and the PV panels on top. So it is a topic that we are very much involved in, and it is a topic that if you're an EPC or if you're doing larger projects, it should be something that you should be aware of at least. And we hope that we provide a little bit of information as to some topics of concern or topics of interest, and where to go and who to talk to in terms of the questions to ask and what you're putting on the roof. We have a webinar in November as well on this is tile. This is the roof screw, isn't it? So yeah, we have a webinar that we've just put on in the chat as well, which I believe will be in terms of roof screws through insulated tile roofs with Hiko, which is a screw manufacturer, not so far away from where we are in Germany. We've been working closely with them to get specific roof screws effectively to better suit situations where you might have insulation between the structure of the tile roofing. So that was a bit off topic, but it just came up into our chat, so we thought we'd introduce it as well. If you'd like to join, you're very welcome. We would love to have you here as well. But if not, that's okay. We have one. I think we have one. But thanks, Klaus. We have a sample over here now as well. But so thank you everyone for joining. We know.
I have one question. What about the K2 community?
That's a German-speaking topic.
Oh, it's only in German? Yeah. That's a pity. Okay.
So we do have a online community, which is currently in a bit of a beta phase in the German-speaking community, where we do have interaction between installers and interaction between installers and K2 personnel in terms of just asking questions about maybe what's the best way to do a roof hook and all sorts of other different things actually, but it will come for the English-speaking world or audience shortly, I believe. Okay, cool. So I hope to see you there soon. We're going a bit off topic, but thank you for joining, everyone. Klaus, who makes the magic happen. Juliane, I know this was your first webinar. This was fantastic.
Yeah.
We hope to see you again next time, and until then, stay safe. Yeah.
Thank you. Bye-bye.